Hi guys, let us today understand what is KVL, Kirchhoff's voltage law. So it is the algebraic sum of all the voltages around any closed loop in a circuit is equal to zero. So mathematically, summation of the voltage equal to zero. What it is trying to say is that if there is a voltage source like this, and after that, let's say there is another voltage source like this, and there is one resistance like this, then another voltage source like this, and another resistance like this. So what will happen is that, and let us understand, the current is flowing in this way, which is I. And let's say these are E1, E2, R1, E3, R2, like that. So what it is trying to say is that E1 minus E2 minus I1 R1, sorry, I mean R1 into I, minus E3 minus of I into R2 equal to 0. So that's what it is, the summation of all the potential equal to 0. So now, how to consider this resistance into voltages? So that is one thing we need to understand. Now let me tell you one critical concept of how to convert it, this resistance into voltage. Now we all know this, the larger line is the positive side, positive plate, and the smaller line is the negative plate in any battery system, right? And in this case we are expecting the voltage, current will flow in this direction. It means the current inside the battery is flowing from the negative to the positive direction. So mind it, inside the battery it is flowing, current is flowing from negative to the positive. Now there is, let's say, another battery just connected opposite to this. Here the positive is in this side and negative in this side, right? But let's say this is 10 volt and this is 5 volt. So what will happen to this case, where the current will flow? Current will flow in this direction, right? From the positive to the negative inside the battery. So mind it, inside the battery. And let's say there is a resistance connected with this R, and this is a circuit, right? And current I is flowing in this direction, that we have already considered. I is flowing in this direction. Now understand this concept. This is this voltage, this voltage source. So how this voltage source is acting in this circuit? It is acting as a resistance to this voltage source. So as a result, the resultant voltage source will be how much? Is it is going to be 10 volt minus 5 volt equal to, it is going to be 5 volt. So now we can consider this 5 volt as a resistance, right? It is working as a resistance. So same way, with the same concept, we can convert a resistance into a voltage source. We can think of it in that way. That is what is the fundamental of KVL. So when current is flowing through a resistance from this direction to this direction, it is simple that this is the positive side, this is a negative side. So if I want to convert it into a voltage source, how it will be look like? It will be look like this. Let's say, let me draw the circuit again. So this is the 5 volt one, this is the positive, this is the negative, and again this is the positive, this is the negative, and this is how it is. So this is positive, negative, positive, negative, and the resistance has become positive, negative with I into R. This is the voltage here. So in this case, what is going to be happen? Right? What is going to happen? This is 5 volt. This is 10 volt. So 10 minus 5 minus IR equal to 0. That is what KVL is. Now, let me take one example, a little more realistic. Let's say this is a voltage source, and there is a resistance here, and there is one more resistance here, one more resistance is here. With this, one resistance is here, one resistance is here, another resistance is, let's say, here. So if this is the case and we want to find out the current here, and let's say this is E1, R1, let me do this one, this is R2, this is R3, this is R4, this is, sorry, this is R5, this is R6 here. Now if the current is flowing in this direction, we are assuming it, right? So if our assumption goes wrong, what will happen? We will get a negative sign in the result. And this is I1, this is I2. So using this KVL, we can very easily find out two equation. One is E1 minus I1 R1. Now why it is minus R1 I1 R1? Because this is positive, this is negative, because we have assumed that the current is flowing in this direction. So since it is positive, it is negative, so it will be like voltage equation will, voltage symbol will be something like this. So it is working as against to this, so that is why negative. Now what will happen to this scenario? Because there are two current, so we are again assuming that I1 is greater than I2, so I1 minus I2. So this, with this understanding, I1 is this one, I1 is this side, and I2 on this side. So we are assuming that the I1 is greater than this, so current is flowing from this side positive to this side negative. So once we are assuming this, so it will remain same for the rest of the analysis. Now, so with this understanding, so it is I1 minus I2 into R2, right? And then again in this loop, current is flowing from this side to this side. So this is positive, this is negative, again this will be minus I1 R6, which is equal to 0, right? And the second equation is going to be again, here what is happening, here we are considering this is I2, and we have already know that this voltage source will be something like this. This is positive, this is negative. We have already assumed that that the I2, sorry, I1 is greater than I2, I1 is greater than I2. So this is, this voltage source is like this. So now I2 is flowing in this direction. So if you look at this voltage source, I2 is flowing from the negative to positive. It is just like the primary voltage source. So in this case, it will be positive, right? So it is like I1 minus I2 into R2 minus I2 R3 minus I2 R4 minus I2 R5 equal to 0. So two equations are there. Now you will see most of the time you will have a lot of parameters known, and you can find out other parameters. And not only that, if it becomes a little more complicated, you can do KCL analysis also. There is one node here, there is one node here, so you can apply KCL, so you will get more equations to solve. So more number of equations are there, then you can solve more number of variables. So that's what KVL is. I hope you have got a clear understanding about what is Kirchhoff's voltage.